Welcome to Visipy. My favorite math story is also one of the darkest stories out there, and it's highly related to logic and the truth value of propositions. It all began in the old land of middle math, in the island of Logica, and in recent times. Actually, at the beginning of the 20th century. You see, in 1902, propositions could only take two values: true or false. However, a great logician called Bertrand Russell, influenced by the investigations of George Cantor, dared to explore the dungeons of an old forgotten prison. There, he left some monsters of antiquity free, monsters that manhood had rarely faced before in their scarier forms, the paradoxes. Moved by his curiosity and studying them carefully, Russell created one of his own, called nowadays the Russell paradox. He didn't know the panic that these monsters would generate in the logic island, especially his, which would also affect the world of mathematics in its very foundations. A paradox is a proposition whose value of truth cannot be determined because it seems to contradict itself. For example, one of the oldest monsters was called the liar's paradox, which can have multiple forms, but the most common is the sentence, "This sentence is false." Think about it. If the sentence is true, then what the sentence is saying is that it is actually false, but that implies that the sentence is false. Now suppose the sentence is false, that would mean that it is not the case that this sentence is false, but then it must be true. In the case of Bertrand Russell, he used set theory, an area of mathematics, to create his paradox. This monster was scary because before that time, mathematics were considered to be not contradictory at all. But Russell's paradox showed that the foundations of set theory weren't all that solid, and mathematics could be attacked from there. To understand the paradox, you only need to think of sets as something like collections of whatever you may think, so there can be sets of cats, sets of M&Ms, and even more, sets of numbers. Whatever thing lies inside a set is called an element of a set. And because you can make a set of almost anything, then you can have sets of sets. Taking our previous example, cats are elements of the set of cats, and this set belongs to the set of all sets of animals. Taking even a bigger example, you can think of the sets of all sets. That sure is an enormous set, which is also known to generate Cantor's paradox. Let's see some mathematical notation. To write that something is an element of a set, we will use a version of the Greek letter epsilon. In this case, this M&M is an element of the set of M&Ms, and this cat is an element of the set of cats. To express sets in a short way, mathematicians use the following symbols, which are read like this: X such that X is an M&M. Similarly, this is the set of all X such that the X's are cats. Finally, to say that something doesn't belong to a set, we'll cross the epsilon. For example, this rabbit doesn't belong to the set of cats. Now let's see what Russell did. Well, he expressed the following concept. Think of the set of all sets that do not belong to themselves. And for short, call it A. From this point, ask the question, does A belong to itself? To answer it, let's suppose that it is true that A belongs to itself and see what happens. Well then, A must have the property that its definition establishes. That is, A doesn't belong to itself. Wait, what? This is a contradiction. Because we don't want contradictions, it must be the opposite thing. That is, it must be false that A is an element of A. Then it is true that A doesn't belong to itself. But this means that A satisfies the definition of A, and if it satisfies the definition, then it must be an element of itself. But this is again a contradiction. See the paradox now? This little monster, among other factors, generated the latest crisis in the foundations of mathematics, and it was only because mathematics had problems assigning a truth value to a simple sentence. Thank you very much for watching. If you like the videos, like, subscribe, comment, or share. See you next time.